Kitty Morgan back again for some more math fun. Yay! And this is page 6 of the AP Stat Student Pack. And this example asks us to talk about a survey of adults. And it says, which make of car do you most prefer to drive? And then it says that that response also had gender recorded as well. So this is a little different. We've thrown another kind of way to look at data in there. So now we have which cars do you like to drive and are you female or male? So the first thing I'd like for you to do is I'd like for you to find the totals for each column and each row. Find the total for each column and each row. Because these are on the margins of this table, this is called marginal distribution. I know, very cool, huh? And another way to think of marginal is it is a subcategory. Like the total, you're going to end up putting all right here. I don't know how many people these are. You'll figure that out in a minute. But the total of female is a subcategory of the entire total of people. Okay? So marginal distributions or marginal frequencies will happen on the margin of the table, and they are subcategories of the total population. So in a moment, I'm going to ask you to stop the video, and when I do, I would like for you to complete the totals and also go underneath and do the relative frequencies of each marginal frequency. So you're going to have the number of people and also the percentage of people, okay, the percentage of relative frequency. And that will actually answer number 1, the marginal distributions and counts and percentages. Okay, so I need you to stop the video now. When you come back, we'll have it filled out and we'll be able to continue our problem. All right, so check your answers and make sure we got the same totals, because that will really mess us up a little later if we don't have that. Notice that I have the totals for each column and row, and both those two numbers should add up to 1154, as well as those three numbers. I always double check that when I work with these frequency tables. And I put the relative frequencies out besides. These are in percentages because that's what it asked for. Okay, and so the next thing we're going to do is we're going to make a graph. And if we're doing a graph of categorical data, we've talked about a bar graph, so we'll probably choose that to do this time. And it asks us to graph the marginal distribution of gender. And so that means that the variable that we want to look at is gender. And the variable of gender is either female or male. So we're going to be putting some female or male totals, because that's the marginal, onto a bar graph. So I'd like for you to make the little L, as I call it, the horizontal vertical axis, and then I'd like for you to label both the vertical and horizontal axis and try a bar chart with a female and male. Let's see, it said in percentages, so the relative frequency in percentages, right? In percentages. And so stop the video. When you come back, we'll see what you got and see how close or how different ours look, okay? All right, come right back. Notice that I have labeled my variable down here. This is the gender. I've labeled on my y-axis, which I actually got to write sideways. Yay! Looks a little better. I labeled the percentage of the marginal frequencies. Or you could just say percentage of relative frequencies. And then I went through and did female and male. To determine my y-axis, I looked over here and said, okay, I have 44.8 and 55.2. So I need at least 60, I would think, on my y-axis. So I just went by tens and guesstimated where 44.8 was. And notice that I put that number up top. And the reason I did that is because it's not as clear where that is. And so you kind of need to indicate. It should be close to your scale, and then it should make more sense with that number. Here's your male, and then went up to 55.2. All right, let's look at number 3. In number 3, it says, now calculate the conditional distribution for gender. In other words, and this is very important, given that the respondent is female, what is the probability that they prefer American, European, or Japanese cars? And then we have to do the same thing for males. So what does this mean about how we look at our chart? Let me grab that chart real fast. So it says, first of all, I don't know what conditional probability is, but I'm going to figure that out. We're going to talk about it. Ooh, I need the one with the numbers, don't I? Sorry. I have several copies of things around here. So, let me grab it. Here's my chart. And it said, it being the number 3, said, given that the respondent is female, that means that I can only look at the females. That's what it means. Given, so right, I can only look at females. Given that the respondents are female. So the reason this is called conditional probability is because I put a condition on the population. I can only look at these people. Only look at these people. Okay? So because of that, the probability population, the denominator will be 517 because I can only look at the females. It will not be the 1154 of the whole population because we put a condition on the population. So my denominators for all 3 of my probabilities are going to be 517. And then the numerators are going to be the numbers that correspond with American and female, European and female, and Japanese and female for the top. So let's write that down and get that going. So I've set up a little kind of organizational thing for me. So I have female, and because it's given that the respondent is female, the denominators have to be the total of females, which is 517. Okay? The top has to be the females that like American. So again, let's look at that chart a little bit while we're doing both of these. We can just kind of do that over the side. So that is 169. So you can see where I'm getting those numbers. For the European, it's only the female can I look at, and that's 214. And then the Japanese is 134. So what I would like for you to do right now, in just a moment, I'm going to ask you to stop the video again. You've got to practice how to do this so it becomes second nature. So I know I keep saying stop and work, but if I don't do that and you just watch me and you don't actually do it, it won't come natural to you because you hadn't practiced it. So I would like for you below to find the relative frequency of that. And then I'd also like for you to set up the male and the relative frequency of that. And I think we're going to do percentages, so let's do the relative frequency and percentages down here if we can. Okay? All right. So I'm going to ask you to stop the video now. When you come back, we'll have this filled out so we can check our answers, and we'll talk about number 4. All right. Let's check our answers, make sure we're doing okay. Notice that for the male, given that it is male, that denominator is all the same, but it's 637 because that's the amount of males that we have. And then I had to put those categories that were under male as a numerator.